All right, welcome back. Here we are talking about timers today. So what we're going to do today is we're going to go online and look at some timers and have some fun stuff with that. So we've already got our PLC configured. We've got the three modules. We've got the correct part number here for the product. So we should be able to go online and all that business. Just double check our tags here, make sure we have a timer tag. And yes, we do. We have a total of 10 timers. So we have our timers as well. To quickly go through that again, we'll just go create a new tag. I'll just call this my timers, and then I'll come down here and hit the data type of timer just to remember how we do timer. The data type has to say timer here. Otherwise, it is not a timer. You just call it a timer, but it's not really a timer until it's the data type of timer. So I go ahead and create this, or I can come in here and say I want, say, 10 of these of my timers, and I hit OK there, and then go ahead and create. And now at this very time, I will have a total of 10 of my timers. So just a quick review of how to create that tag. So now we do have timers. We got lots of timers. I got timers and my timers. So we go back into the main program here. We're going to go over to routine, main routine. As you can see, one of the first points I want to bring up is we're in the main routine. We got ease over here on the left-hand side. Ease means we have a problem. What the PLC is saying is that you have an empty rung of logic. It does not like empty rungs of logic. If we try downloading this, it's going to give me errors saying that you have an empty rung of logic. So if we have ease on the left-hand side, it's a real good indicator that it's not going to let you download. So you do need to be aware of this, okay? So when you see anything to the left side of a rung, that's a good indicator that there's a problem. So keep that in mind, all right? So what are we going to do here? We're going to come in here. We're going to add some contact, add a contact, and then I'll come over to timers and counters. I'll incorporate first the timer on. Oop, I didn't plan on it. Timer on is considered to be what? An output command, not an input command, so it's got to go where? It's not here, but here. I'm not sure why I tried putting it there. Why is it trying to put it there? What am I doing wrong here? Usually it lets me select whatever I want here, so I'm just going to grab a binary zero here. Let's try that. Why is it putting it there? I don't know what I'm doing wrong here. I've never seen it do this before. I have no idea what took place there. I don't have any idea why it's trying to put the timer on the input side, but it always belongs on the output side. This is a good spot to make a point. I will not accept any logic that has outputs in series. So what I'm going to illustrate here is that this PLC program will allow you to do something like this, some crazy stuff like this. I'm not accepting this. This is baloney. This is not. You will not see logic like this in industry. So if I see any logic with two outputs on the same rung, I am not giving credit for any of it. So keep that in mind. I will also not accept any latches or unlatches in any of my That's these latches. This is a latch output. This is the unlatch. This is a form of programming that I see from time to time with machine builders. It's a solution that works, but it's very complicated. It makes for some very difficult troubleshooting. I have never once experienced a situation where a latch and unlatch couldn't be solved using standard seal-in circuits. So in this class, we are not going to use those. I'm only going to accept seal-in circuit for a solution. So if you come to me and explain to me why you have to use latches on latches, rest assured, I have been in many arguments with many machine builders in the past, and I have proven them that I could do everything that they could do with their latches and latches without using those. So, so don't. You're welcome to present your argument. I will hear it out, but don't count on it. Okay. All right. Moving along. So first piece of this, I have to grab a timer address. If I don't grab a timer address, what am I going to get? I'm going to get errors. Notice how I created timers so it automatically populates this, so you're making sure you're grabbing the right information. If I went over here and tried grabbing, if I go alt tag, say I grab a double integer, and say I want this to be solved, I'm going to come over and verify wrong. You see, notice the first thing it gives me is invalid data type. So this is the indicator that you need to know that I selected the wrong data type for this problem. So I have to come over here. I come in here, I got to put timer in here. I'll put timer 0 in there. As you can see, as soon as I put timer 0 there, the e's went away. That's what I'd anticipate. The preset for these timers is a little different than the 500 world. They use the millisecond base, okay? So that means for us is that we can't select the base value anymore. So if I want to put a value of, say, 1 second in there, what do you believe I have to enter in there? Exactly right, a 1,000. So if I want a delay of 1 second, I have to put a value of 1,000 in there, okay? Let's go ahead and download this piece of logic here and see what takes place. All right, downloading this, blah, blah, blah. Okay, so as you can see here, here's a few points that I want to bring up while I'm in run mode. Is the run mode light turns on, I'm controller okay, and IO is okay. I have green lights for all 3 of these points. I'm in run mode. These are all components that you need to be aware of. If you come to class or come to lab and you're taking one of my lab exams or any exam, and you failed to put it into run mode, and your logic's not being solved and you don't know why, this is not going to bode well for you, okay? So just be aware that I want you to understand that in order for the PLC to solve logic, it's got to be in run mode, okay? So next same piece of this, I'm just going to go ahead and toggle this guy. So I'm going to come over here and toggle this on, and as you can see, it counts. Next piece of this I want to share is that you notice where this is on, I see the enable bit and the done bit on at the same time here. So you saw the enable turn on. I'll go ahead and toggle it off and back on again. You see the enable bit turn on immediately, and then after the second, you see the done bit turn on. These are a couple of points that I want to share with you. This is how the timer works. The enable comes on immediately, and then the done bit turns on after that. If we wanted to create some more logic here to help illustrate that, I'm going to go ahead and go offline here. I'm going to create a couple of rungs here. I'm going to grab this and this. Oh, there it goes again, putting it in the wrong direction. Maybe I'll delete these. It's always easier to copy and paste. So I'm going to show you guys how this guy works. A little paste here. Oh, paste here. Because creating logic is always it takes more time. So keep that in mind. We got timer 0. Something else we can do, we can grab this information, drag it over here, and then it just come down here, and I'm going to have enable. Oh. I can grab this and bring it down here. Timer timing. Notice how fast this is. This is something I want you guys to get kind of used to. This is in the simulation software. Allows you a lot of this to do the same. Lets you do the same type of operations. Here I'm just going to grab. See here, I've already used binary 0. I'm going to use binary 1. Binary 2, and binary 3. I'm going to go ahead and download this. I got enable, timer timing, timer done. I just want you guys I want to illustrate how this is all tied in to the PLC, into the timer. Okay, so now we've got enable, timer timing, timer done. Now we can watch how these bits respond to the timer itself. I'm going to toggle this back on again. You'll see the enable and the timer timing turn on immediately. See these guys turn on. Timer timing turns off and done bit turns on. I put a value, say, larger than 1,000. Let's go 5,000. Maybe that'll give us some more time to view this. So I'm going to toggle this back off again and toggle it back on again. You will see here as it's counting to 5,000, the timer timing is on and the enable is on, and then when it completes, it drops the done bit on. So another piece of this I want to share is if we go to controller tags, we can see the very same operation. This is something I want you guys to get really comfortable doing, is understanding the data table. So the data table here, as you can see here, when I expand on timer 0, I get 5 components. I get the preset word, the accumulated word, enable bit, timer timing bit, and done bit. These are all components of the timer, if you remember right. The preset is a 32-bit word, the accumulator is a 32-bit word, and the enable, timer timing, and done bit is a part of a control word that is actually 32 bits long, but we only see the 3 bits of it. So that's those 3 pieces of that word. So when we're looking at timers, what Allen Bradley does for us is it shows us the relevant pieces of that timer. Anything that's outside of that, we're not really concerned with as it is internal to the PLC. So we're looking at the 5,000 is the preset, 5,000 is reached the accumulated value, enable bit is on, the timer timing bit is off, and the timer done bit is on. Noting that these ones and zeros and this 5,000 and 5,000 represent what? That timer. Okay? As you can see, preset is 5,000, accumulated value is 5,000. The enable bit is on, the timer timing is off, and the done bit is on. So yes, there's a direct correlation between the controller tags. We look at this information here. And we look at this information here. You see here, enable is on, is set to 1. Timer timing is off, set to 0. And done bit is on, and as you can see, a 1 here. So there's a direct correlation to the data table and the ladder logic. When I state, you'll hear me say it multiple times, is a PLC, when you think of a PLC, everybody thinks of ladder logic. What I want you to think of is a data table. All that information, all the ones and zeros, all the ladder programming, all that business is actually doing nothing more than reading and writing to those data tables. That's all we're doing. For instance, if I look at this binary sequence here, binary 1, 2, and 3, I pulled it up for a second there. You look at binary, you will see a series of ones and zeros. Let's do a comparison here again. Binary 0, 1, 2, and 3. And then we go back to the main routine. And I pull that back up again here. Notice we have binary 0 is on contact, or it's equal to a 1 in the data table. Binary 1 is on, and that's a 1 in the data table. Binary 2 is off, and it's a 0 in the data table. And binary 3 is on, and it's a 1 in the data table. So I want you guys all to get a solid understanding that troubleshooting in a PLC can be done in the data table, and sometimes a whole lot easier than in the ladder logic, because you can look at multiple bits from one location. So keep this in mind when you're developing your code and whatnot. If you do a good job organizing your code, that you can use a data table to help troubleshoot larger portions of code faster. Okay. So that is my piece on the timers, on the timer on, excuse me. Next piece we'll be talking about timer off.